Welcome to Study Loop.
19.57, so we have this circuit where the switch is closed at time 0. So we want to find the initial currents at time 0 and the currents at time equals infinity, which we can do by redrawing the circuit in a simpler way that applies at those two particular points in time. And then we want to find the voltage across the capacitor at t equals infinity as well. So the simpler circuit that we get at t equals 0 starts when the capacitor, so when the capacitor is uncharged, it instantaneously behaves like a short circuit. And so if we replace this with a, just a wire, we'll get the equivalent circuit at t equals 0. So we have our first resistor here, our second resistor here, and our third resistor here, and the capacitor just behaves like a wire. So we see that we have a resistor in series with two resistors in parallel, and they all have the same value. So the equivalent resistance, this has a value of 1/2 R between these 2 points, and then that's in series with 1 R, so we have 3/2 R. So that's the total current through the battery. The total current through the battery goes through 1 here. So I1 equals V over the equivalent R. I guess this should be an E. So E over R equivalent, which R equivalent is 3/2 R. So we get 2E over 3R. And then because these resistors are in parallel and have the same value, I1 splits evenly between them. I1 is always going to be I2 plus I3, and I2 and I3 are going to be equal because the resistors have an equal value. So I2 equals I3, which is 1/2 of this. So that's E over 2R. Now, when we go to time of infinity, the capacitor is fully charged, and so it acts like an open circuit. And so our simpler version of the circuit, we just take this entire branch out because no current is going through it. So right off the bat, we can say that I3 is equal to 0. Just using the heuristic, this behaves like an open circuit. And so if there's no current able to flow through here, then the element that's in series with it can't have any current either. And so then the equivalent resistance is just 2R. And because 1 and 2 are in series, they have to have the same current. Which will be E over 2R, because this is the equivalent resistance. So now for part C, there's no current through this resistor here, resistor 3. So that means there's no voltage drop across it. And since R3 and C are in parallel with R2 here, then whatever the voltage across R2 is going to be the same as the combination here. And because there's no current, there's no voltage drop across R3. So the voltage on the capacitor is going to be equal to the voltage across resistor 2. We know that the current through resistor 2 is E over 2R. So by Ohm's law, this is I2 R2. So this is R times E over 2R, which just gives us E over 2 because then the R's cancel.